This is our last question in non-singular matrix section C50. And in it, we want to find the null space for vector E. Now, vector E turns out to be a square matrix, but that doesn't mean that we can't find its null space. Remember, to find the null space of a vector, or excuse me, a matrix, it means we treat it as if this is the coefficient matrix for a homogeneous system. And in order to do the reduced row echelon form, I first need the matrix to actually indicate its true form. To be homogeneous, it's got to have a final column of zeros. Now, of course, this no longer makes it matrix E. Matrix E is just from this column to this column. But nonetheless, this is our augmented matrix that we need to then put through RF. In order to see what the nature of the solutions look like, because remember, the null space for a homogeneous system is the solution to the system. So we've got to look at what the solution looks like, and the reduced row echelon form will show us that. Okay, what does it turn out to be? That's what it looks like. 1, 0, 2, negative 6, 0. Line 2 is 0, 1, negative 5, 3, 0. And then the last two lines are all zeros. Okay, so there's a lot of freedom in this one. There's only two pinned variables, so r is equal to 2. So that means we've got our dependent variables are in columns 1 and 2. We don't have a pivot in our last column, so that means there's solutions to the system. That means our free variables are columns 3 and 4. And they're doubly free because, of course, we've got two equations with zeros in them. And again, n equals 4. There's 4 variables. So columns 3 and 4 are free, so x3 is equal to A, and x4 is equal to B. And then that gives us that x1 is going to be equal to 6b minus 2a, and x2, which is our second dependent variable, tells us that it's going to be 5a minus 3b. So there it is. That'll be the solution to our system, and of course that makes it the null space for matrix E, our original matrix E, this guy right here. And as a solution set, well, actually this time, let me break with convention and actually write it as the vertical matrix. So x1 is going to be 6b minus 2a. X2 is going to be 5a minus 3b. X3 is going to be a, and x4 is going to be b. And then that matrix is all subject to A and B being elements of the complex number set. And that's it. So there it is, written in the way the textbook likes it to see, as a vertically oriented vector. And remember, a vector is just a single column matrix.